basics of how spirometry can help you in making a diagnosis of underlying cause of a cough, a dry cough. So remember that spirometry is a gold standard diagnostic test for obstructive airway disease, such as asthma and for COPD. In fact, the Global Initiative for Obstructive Lung Disease, which is a COPD guidelines committee, they recommend that if you want to make a diagnosis of COPD, it is mandatory, it is compulsory to have spirometry prove that diagnosis. So you cannot make a diagnosis of COPD without doing spirometry. I think that's the message. Then you can demonstrate presence of reversibility. Good bronchodilator reversibility often suggests asthma, and a poor bronchodilator reversibility can also be seen in asthma, but more likely to be seen in COPD patients as well. Then you can grade the severity of the obstruction, identify presence of restrictive lung disease, assess the response to treatment, follow-up tool. You can also use spirometry for pre-surgical evaluation and for smoking cessation. So these are all additional benefits of spirometry, but from a diagnostic point of view, these are the most common conditions. Now, how does a spirometer work? What is the fundamental principle? Now, what I would like all of you all to do is to take a deep breath inside. Nice deep breath. Fill your lungs with as much air as possible. Now imagine I have given you a big size straw, a big bore straw. Put it in your mouth and blow out forcefully. Remove all that air as fast as you can. If you've imagined doing that, then I'm going to ask you to take another deep breath and fill your lungs with as much air as possible. But this time I'm going to give you a small straw, small bore straw, and ask you to remove all the air from the lungs as fast as possible. So what do you think? Which size straw will help you remove the air faster from the lungs or to empty the lungs faster? Will it be the big bore straw or the small bore straw? The answer is very simple, isn't it? The bigger the bore of the straw, the earlier, the faster the lungs will empty. And that's the principle that a spirometer uses. So if your airways become narrower and narrower and narrower and narrower, it is going to take a long time for you to remove that air out. And that is what spirometry measures. How long does it take to empty the lung out? Now, here is an example of an animation which I hope will explain to you what I've just said. So these are all the alveoli, the lungs that I have collated and put all together and put all the airways together as one airway and one big alveoli. They can see that this is a airway that is healthy from a healthy subjects. So there is a nice, big, wide lumen through which air goes in and out. Now this person has taken a full deep inhalation, like how I had asked you to do before. Now when I say blow out as fast as you can, see the amount of time that it takes to empty this lung. You saw that? Okay. Now I'm going to show you a patient who has got obstructive airway disease. See the size of the lumen over here. So the lumen has become narrow, small size straw now. The lung parenchyma looks the same. So this patient has taken a nice deep inhalation. And when I say blow forcefully, see how much time it takes to empty this lung. Did you appreciate this? So if you have a healthy airway, the air will come out very fast. If you have got obstructed airways, the air will come out very slowly. So here is again the reminder of a healthy person. See how fast the air comes out. Now, if I measure that volume of air that comes out after taking a deep inhalation, that volume is called as forced vital capacity. Why is it called forced? Because I'm removing that air with force. Why is it called vital capacity? Vital capacity is the volume of air that you can remove after taking a full deep inhalation. That volume of air that you remove is called as vital capacity. And if you do that with force, it's called forced vital capacity. So here it is. Forced vital capacity is 4 liters. Now this is a normal, healthy individual. His value is 4 liters. Now, forced vital capacity can now be broken down on an x-axis in terms of time. What do you mean by that? What is the amount of air that comes out of the amount of volume of air that comes out of the lungs in the first 1 second, this volume of air compared to this is becomes your FEV1. What is FEV1? Forced expiratory volume in the first 1 second. So this is the volume of air that came in the first 1 second. In 2 seconds, this is the volume of air that came, called as FEV2. In 3 seconds is this, 4 seconds, 5 seconds, and 6 seconds. Now, I want you to appreciate two things over here. Very, very important. The volume of air that you remove in the first 1 second, when you compare that with your FVC, this volume of air is more than 70%. Okay, FEV1 divided by FVC is more than 70%. The other thing is, if you see that when you start blowing, the air comes out, then it reaches a peak over here. And then from there, it's a flat line. Why is there a flat line over here? There's a flat line because it means that all the air has already come out. There is no more air left to come out. So that's why this line is not going to go up. It's going to stop over here. And then you'll get a flat line. In a normal healthy individual, you start getting a flat line or a plateau at about 2 seconds. Okay. Now keep these two things at the back of your mind. FEV1 is more than 70% of the FVC, and you start getting a plateau by around 2 seconds. Now I will show you what happens in a patient with obstructive airway disease. Okay. So again, to show you that hallucination, person has taken a nice deep inhalation and blows out very forcefully, but this takes a long time. Now, FVC is the same as that of a normal healthy individual. So FVC does not change much in patients with mild or moderate disease. But see what happens to the time scale over here. The volume of air that you remove in the first 1 second is now this one, FEV1. Volume of air removed in 2 seconds is this, 3 seconds is this, 4 seconds is this, 5 seconds is this, 6 seconds. So the two things that I'll ask you to keep a close watch. FEV1 divided by FVC is less than 70%. That is diagnostic of obstructive airway disease. Okay, that ratio, FEV1 upon FVC, if it is less than 70%, it is obstructive airway disease. The second point, as I told you that the FEV, the plateau is reached by about 2 seconds in a normal, healthy individual. 2 seconds. After 2 seconds, it's a flat line. Now see, there is no flat line over here until patient has reached blown for 6 seconds. So when there is no flat line for up to 6 seconds, then it is indicative of obstructive airway disease. Because I remember that small straw and a big straw, it takes a long time to remove all that air out. And therefore, you don't see a plateau at 2 seconds. You remove all that, it takes a long time to empty the lung. Simple. So this is actually what you get in this graph called as the volume time graph. Volume on the y-axis, time on the x-axis, time is in seconds, volume is in liters. So the volume of air that you remove in the first 1 second, this point, this is called as FEV1. The maximum volume of air that you remove, the highest point over here, is your FVC. FEV1 and FVC are very close to each other, so the ratio will be more than 70%. So this is no obstructive airway disease. The second graph that you get in a spirometry report is flow volume. Now in the previous one, you can see that volume was on the y-axis. So the highest point becomes your FVC, forced vital capacity. In the flow volume loop, you can see that the volume is on the x-axis, not the y-axis. So the point that is furthest to the right on the volume axis, this becomes your FVC. And then this is the flow, this is the speed with which the air comes out. The highest point that you reach over here, highest point, this is the maximum speed with which the air came out. This is called as the peak expiratory flow rate, or PEFR. This is the same value that you get in a peak flow rate. Okay. The expiratory loop is the shape of a triangle, and the inspiratory loop is the shape of a semicircle. Okay. Now this is the PEFR, and this is the FVC. The other parameter that we get in the flow volume loop is FEF 25 to 75%. What is FEF 25 to 75%? So if this is my 100% of the FBC, 0% to 100%, 50% will be here, right? 50% will be here. Then 25% will be here and 75% will be here. So what do? I draw a line from 25% of the FBC upwards, which reaches over here. Then I draw a line at 75% of the FBC, draw a line upwards, which is here. So the average flow between 25% of the FBC, which is here, to 75% of the FBC, which is here, that is called FEF 25 to 75. And it gives you a very useful information about small airways. So whether there is small airways obstruction or not will be found in this parameter called FEF 25 to 75. Now, how do you diagnose obstructive airway disease? Let me take you through this interpretation of spirometry in literally 3 minutes. Volume time graph. Volume of air removed in the first 1 second is called FEV1. Maximum volume of air is called FVC. And the point at which the plateau starts, the flat line starts, is around 2 seconds, 2.5 seconds. Okay. Now, when this person develops obstructive airway disease, this is the shape of the curve, mild obstructive airway disease. So what has happened to the FEV1 value compared to that of a normal healthy individual? The FEV1 value has come down. What has happened to the FVC value? Oh, the FVC value is the same as that of a normal healthy individual. The highest point is reached over here. What is the difference over here? The plateau starts appearing at around 5 to 6 seconds over here. In a normal healthy individual, the plateau starts at around 2 to 3 seconds. In mild obstructive airway disease, FEV1 value is reduced and a plateau starts coming at 5 to 6 seconds. There is a plateau over here, but it has come much later. This is mild obstructive airway disease. In moderate obstructive airway disease, this is the shape of the curve. FEV1 has now come down a lot. FVC is the same as that of a healthy individual. Is there a plateau over here? No plateau for even 6 seconds. Then this is moderate obstructive airway disease. In severe or very severe obstructive airway disease, this is the shape of the curve. Okay, so what has happened to this? FEV1 value is significantly low. FVC value is also low over here. And there's a line that seems to be going up and up and up and up forever. Low FEV1, low FVC, and a line that keeps on going up and up and up forever is severe obstructive airway disease. Isn't that simple? By merely looking at the shape of the curve, where do you reach up? Does the patient reach the highest FVC value? Is there a plateau? At what point of time does a plateau start? If you answer those questions, you will get to know whether the patient has mild, moderate, or severe obstructive airway disease. Simple. If you think that the flow volume loop is simple, then the volume time graph is even more simple. I'll show you how to make a diagnosis. So I told you that this is the maximum flow. This is called as the peak expiratory flow rate. This is called as FVC. Okay. Now, when a person develops mild obstructive airway disease, this is the shape of the curve. What has happened to the PFR value compared to that of a normal healthy individual? Same. What has happened to the FVC value compared to that of a normal healthy individual? Same. But in a normal individual, from PEF to FVC, it's a straight line, as if it's drawn with a scale. You can see that this has now become concave. Normal PEFR, normal FVC with a concavity is mild obstructive airway disease. Moderate obstructive airway disease looks like this. What has happened to the PFR value? Significantly reduced. Here it is low. PFR value is low, but FVC is normal and the concavity is more. So low peak flow, normal FVC, and concave line over here is moderate obstructive airway disease. In severe or very severe obstructive airway disease, you can see that the peak flow has gone down. In severe, very severe obstructive airway disease, the FVC is also reduced. Now, instead of being a straight line, it has now become very, 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 very curved. So instead of a 180-degree line, you get a 90-degree line. So the more the concavity, more severe is the obstructive airway disease. If it's 90 degrees with a low FVC, it is very severe obstructive airway disease. So by merely looking at the shape of these curves, you can make a diagnosis of obstructive airway disease and even tell whether it is mild or moderate or severe.